Hello everyone, my name is YUAN. Thank you for being here today. In this presentation, I'll share my research project about using machine learning to predict retail sales based on real data from Walmart. The goal is to find out which model can give the most accurate prediction to help companies plan better. We included 6 parts: abstract, introduction, literature review, methodology, results and discussion, conclusion and limitations. Abstract. Retail is very competitive industry. Accurate sales forecasting is important for managing inventory, reducing cost, and increasing profit. But traditional methods are not good at handling complex patterns. So I used machine learning to test six different models: polynomial regression, rigid, lasso, decision tree, random forest, and XGBoost. I used Walmart's sales data from Kaggle. In the end, random forest gives the best balance between speed and accuracy. This study can help beginners choose better forecasting methods. Introduction. Sales forecasting helps companies decide how much to produce, when to sell, and where to stock. Traditional models like enrollment are simple but not effective with non-linear or conflicted data. Machine learning is better at finding patterns from large data sets. In this project, I used Python to train different models. My main research question were: Can machine learning improve sales forecasting? Which model performs best? How does model choice affect business outcomes? Literature review. Many post studies use simple models like moving average or exponential smoothing. But when data is affected by holidays, promotions, or demand shifts, these methods fail. Machine learning can solve this. For example, polynomial can fit curves but might overfit. Rigid and lasso are regularized linear models better for small data. Tree models like random forest and XGBoost can learn from complex data. However, there are not many studies that compare all 6 models using Walmart data, so my study fills that gap. Methodology, data preparation. The data comes from Walmart's open sales data site. It has 5,000 rows and 33 columns, including item, price, promotion, and holiday info. I cleaned the data and created new variables like whether the sale was on a weekend. I also created a new target called adjusted actual demand. Then I remove outliers, use a gradient boosting model. After that, I selected the top 20 important features using random forest. I use them to train all models. Methodology, models evaluation. I trained 6 models. 1. Polynomial regression. 2. Rigid regression. 3. Lasso regression. 4. Decision tree. 5. Random forest. And the final, XGBoost. To compare their performance, I used 2 main metrics. Mean squared error, the lower the better. R-score, the closer to 1 the better. Random forest has good balance of high accuracy and faster training. XGBoost was slightly more accurate but slower. Results and discussion. Model performance. Here are the results. Random forest has the second best R-score, 0.8711. A very low mean squared error, 1,363.67, just behind XGBoost. Rigid and lasso had poor performance. Polynomial regression and decision tree were okay, but not as stable. So, in sample models like random forest and XGBoost are the most accurate and reliable for this kind of data. Result and discussion, visualization. I also checked the visual performance. In scatter plots, random forest and XGBoost predictions were close to actual values. This means the models are accurate. This error distribution was centered around zero with small deviations. In contrast, the rigid and lasso show large errors. Decision tree has depth effect, meaning it gives the same result for many inputs, not ideal. So again, random forest shows strong, stable results. Conclusion and limitations. To conclude, random forest is the best model for Walmart sales prediction. It's accurate, stable, and faster to train. XGBoost is slightly better in accuracy but needs more time and tuning. These studies show how machine learning can help improve business forecasting. But there are some limitations. The data size is small, only 5,000 rows. No external factors were used, like holidays, weather, or economy. No deep learning or auto machine learning used. In the future, we can improve the model by adding external data, turning the parameters, or using advanced methods like deep learning. That's the end of my presentation. Thank you for your listening. I hope this study gave you a clear idea of how machine learning can help in sales forecasting. If you have any questions, I'll be happy to answer them.